The purpose of this video is to show you and help you create an entity relationship diagram, and this is the starting point for your eventual 50-point access assignment. And in the 50-point access assignment, you will find the detailed instructions for that project, and from there you will get an idea of all of the requirements. For example, a minimum of 3 tables. Each table has to have 5 fields, and so on and so on. So let's talk about entity relationship diagrams. That's all they are. They are diagrams, and their purpose is to help you build your database. So how do you even get started? Well, in the real world, end users would talk to software engineers and tell them, number one, all the data that they need to store and why, all the reports that they need to look at and why, when they need to be generated, and so on. And they would tell the software engineers how this data is related, and when it's created, and where it gets created, and so on. The software engineer would then go back to their desk and they would sketch out a picture of the database, what they think the database looks like, what they think all the fields look like, and how they're all related. And then they would take that back to the end users and get their sign off on it, their agreement that that's how their database looks. And then the database administrator could take the entity relationship diagram and create the actual database. Then it would be up to the users or the software engineer to actually populate the database with actual data. So as a student, where do you start? Well, first of all, I tell students to try and think about a topic that interests them, except for sports, because that's too easy and you can't use this database since we're displaying it. Think about something, music or fashion or hairstyles or something that interests you, or maybe your field of study, and get ideas for databases there. Also, in the assignment and in class, I will discuss with you lots of options for and ideas for databases. So as a student, how do you get started? Well, I often have students write a sentence that looks something like this. There are many A, and for each A, there are many B's. And for each B, there are many C's. And if you can start with that sentence, that might give you an idea of how to create and ideas for databases based on your interests. So let's take a look at this entity relationship diagram. Obviously, there are many universities across the United States, and each university has many classes, and that is indicated by this crow's feet. And each class obviously has many students. Each one of these boxes is called an entity, therefore entity relationship diagram. The crow's feet shows the relationship, one to many. Each university has many classes that it teaches, and each class has many students in them. So entity relationship diagram. In the real world, databases can contain even thousands of entities and millions of attributes. These items in each entity are called attributes. Likewise here and here. So you should know that this is just a drawing, and for your purposes you could even draw it by hand. This is going to become a table called the university table. This entity is going to be called the class table, and this will be the student table. So entities become tables. That's simple enough. Attributes are going to become fields in your database, or columns. And this information next to it is the kind of data that's stored in those columns. And it's pretty self-explanatory. For your assignment, I'm only requiring you to have 3 entities. 1, 2, 3. And you're required to have 2 relationships. In some cases, you could have your primary table in the middle, and it might have many of this attribute to the left, and it might have many of this attribute to the right. And so this crow's feet would be pointing in the opposite direction, and that's perfectly acceptable. Now let's talk about attributes for a minute, and this is often where students go wrong. What you have to ask yourself is, what do all universities have in common? In other words, what fields do we need to store about each university? But here's the trick. It has to be single. In other words, every university has only one name. Every university has only one address. Every university has only one president, only one website, and only one date established. And likewise for the class. Every class has got only one name, one description, one location, and so on and so on. So you have to think carefully, because if any of these attributes are plural, that's most likely going to be wrong. In fact, a plural attribute could mean that you need an additional entity. Again, over here on the right, for each one of these entities, I tell the kind of data that's going to be stored there and the longest possible university name. Also, in some cases, like date, the data that's going to be stored is date type. Over here, it looks like we have all text fields, but in student, we have catalog year, which is date, and we have another field which is called financial aid, and it's a yes/no type of field. Now, the type of data that's stored there, that's called metadata, or background information about the data. So back to your entity relationship diagram. You have to have 3 entities with 2 crow's feet, and within each entity you have to have at least 5 attributes. However, I need to make it clear that address for me is considered one attribute. And name, even though we divide it into first and last, is just considered 1. So if we count, we have 1, 2, 3, 4, and 5. And we'll talk about this field up here in a moment. In class, we have 1, 2, 3, 4, and 5. And student has 5 also. It can sometimes be difficult to come up with fields, but always remember that you need to state it this way. Each university has only one what. This is something that all universities have in common, but they only have one. The next thing I like to talk about is a very important concept in databases, and it's called keys. And like the key to a door, it's unique. The key to your apartment, the key to your dorm room is going to be unique. Of course, your roommate may have a copy of it, but it's unique to your door. Likewise, let's talk about students, because that is something that you can relate to. Let's say your name is John Smith, and it's likely that we have many John Smiths enrolled at our university. So, how do we know one John Smith from another? How do we tell one from another, right? Not all John Smiths have a social security number, especially if they're a foreign student. But interestingly, for IRS purposes, Social Security number is the key to identifying a person for tax purposes. You're actually surrounded by a lot of primary keys, although you don't know it. So you as a student, when you are accepted here at the university, you are assigned a student ID. And it's a unique number. It doesn't have any meaning, a special meaning in particular. It's just the next sequential number behind the last person that got accepted at the university. And it really is not meaningful, except it uniquely identifies you, all your grades, and all your transcripts in the end when you graduate. Primary keys are critical to databases, to relational databases. So let me say this. Every single entity has got to have a primary key. And remember, entities turn into tables, so that means that every table has to have a primary key. So we're always going to put the primary key at the top in its own box. So university ID is primary key, class ID, and student ID. And they're all going to be auto number, the type of data. In other words, the next university that we add to the database is just going to be the next sequential number available. Now the next item of interest is foreign keys. And if you can really grasp the concept of foreign keys, then you have this whole relational database thing down. You get it. You get it. A foreign key is just a field or an attribute in an entity that tells how the entities are related. So, if you'll notice that down here at the bottom, I have a field called Class University ID. And I have drawn an arrow back to University ID. So these are actually both University ID. And this is the way you need to look at it. The foreign key represents the words belongs to. So any particular class, ITM220B, belongs to a particular university. It cannot belong to more than one university. It can only belong to one. So this is the foreign key. Really nothing special about it except that it's last. And it's going to represent the primary key of the table that it's related to. It's going to be the same and contain the same numbers, actually. So let's look at student too. The last field is the foreign key, student class ID. So Joan Smith, as a student, belongs to a particular class. Joan Smith belongs to a particular class. So the foreign key is last, and it represents the word belongs to. So that's about it for entity relationship diagrams. You can hand draw yours as long as your handwriting is very neat. But you must remember that each one of your attributes must begin with the name of the entity or some abbreviation of it. That's why I have UNIV name, class name, class description, student last name, student first name, and so on, or actually STU as an abbreviation. Remember that you have to have at least 5 attributes, not counting the key or the foreign key, and that certain fields are counted as 1, like address or names. Also remember that addresses should always be split up into address, city, state, and zip, and names should always be split up. And don't forget to set your metadata appropriately to the right. So that's it for entity relationship diagrams.